Let's examine the output generated by the following code snippet. How about this code snippet? Congratulations if you managed to answer correctly. However, you might want to stick around to refresh your memory and maybe learn something new. Even though there aren't so many lines of code in this code snippet, there are so many concepts that needs to be covered in order to fully understand what is going on. These important concepts are var and let, JavaScript single-threaded, call stack, web API, task queue, and event loop. JavaScript is a single-threaded programming language, which means that it can only process only one task at a time. Now you may ask me, if JavaScript is single-threaded, how do we have the ability to execute some block of code at a later time without blocking the code execution? Answer: the event loop. Now let's do a quick recap on var and let. What is the output of this code snippet? How about this one? For the first code snippet, the answer is 3. For the second, reference error I is not defined. But why is that? Var is function scoped and let is blocked scope. But how is that helpful to know? Well, in the first code snippet, we don't have a function, which means that the var value has leaked out, and by the fourth iteration, the value 3 terminates the for loop. But because it leaks out of the for loop, the value at this stage is 3, which is the output. For the second code snippet, we use the let keyword. So the value of let is scoped to the for loop, and it does not leak that I value. That I variable has never been declared in the main scope or the global scope. However, the console log lives inside the main scope and does not have access to that I value at all. So it throws that error, reference error, I is not defined. Now let's talk about the JavaScript call stack. It uses a stack data structure. A stack data structure is first in, last out. Think of it as a stack of books inside a box. And to get your last book, which is at the bottom of the box, you will have to remove every book on top of it. The JavaScript call stack is a stack of execution contexts, each associated with a function call. Every time a value is returned, the context is popped off the stack. Have a look at this code snippet and let me know what is the output. The last line calls function A. This creates an execution context, and then this context is pushed to the stack. Function A calls function B, and another execution context is pushed to the stack. Currently, we have two contexts. Now we're inside B function, and the output called B is logged. Function B returned, and the execution context is popped off the stack. And then finally, function logs the returned value from function B. You can call off function A. Finally, function A execution context is popped out of the stack and terminates the program. There are many web APIs and interfaces, however, we'll focus on the setTimeout function. When we call the setTimeout, the web API has a timer running. The timer waits for the specified time limit to be finished. After the timer has elapsed, the callback gets added to the task queue. So you might ask, what is a task queue? The task queue uses a queue data structure. The queue follows FIFO, first in, first out, very similar to a queue of people waiting to get served their coffee. The first person who arrived goes first. So basically, this JavaScript task queue is a queue of tasks that are waiting to be executed. Now to the final concept, the event loop. What is the event loop? The event loop is an infinite loop. It keeps checking the task queue and executes the tasks when the JavaScript call stack is empty. I'm going to repeat this again. When the JavaScript call stack is empty. This is very important. If you made it this far, congratulations. These topics are really hard and each one of them needs a separate video. So if this is the first time you hear about all of these new topics, don't worry. As a bonus, I will go over a few more code snippets. Now let's test your knowledge. Notice the 100 milliseconds and the var keyword. It should be very obvious. The answer is 3, 3, 3 for every iteration because the var has leaked the final I value, which is 3. Do you think you can answer it? Notice the 1000 milliseconds and the let keyword. The answer for this is 0 and then 1 and then 2. And the reason to that is because the I value has blocked scope because of the let keyword, and every iteration I has kept its original value. See, when we had var, what happened? I promise you, only 2 more code snippets. Now, how about this one? Notice the 0 milliseconds and the var keyword. What is the answer, do you think? Even though we have 0 milliseconds, that does not mean it will be executed immediately. So the answer to this will be declared before set timeout, then log after set timeout, and then 3, and then 3, and then 3, in this order. So the set timeout will be the last thing executed. I know it's getting repetitive by now, but how about this one? It will be very similar to the previous one, except because we're using let. The answer will be in this order. The first thing will be declared before set timeout, the second will be log after set timeout, and then 0, and then 1, and then 2. If you made it this far, thank you. And I will be also releasing my handwritten notes, my blog posts, and I will also be releasing the GitHub code. So please stay tuned and see you soon.